Alright, hello. So just a bit of a warning in advance. The mirroring thing is a bit laggy, so I apologize if it's a bit delayed. So we can then jump straight into the simplex method. In the last video, I covered converting to canonical form. Now we're gonna do the whole process from step 1 to step 4 all the way if you read my written notes. So the first step is to convert to canonical form, and so I just jot that down first. And we can see that here we just got less than or equal inequality, so we only need to add slack variables. So to convert it into canonical form, and then we're also going to put it into a table or a tableau. The tableau will basically just help us organize the relevant information. So first things first, we want to convert to canonical form. We only need to add slack variables, so I'm kind of just going to write this down as it is. So the maximum z is equal to 5x1 plus 3x2 plus x3. And then for the first constraint, there's going to be x1 plus x2 plus x3 is less than or equal, so we want to add a slack variable s1, and that's going to be that's going to be equal to 6. And then the next constraint is going to be 5x1 plus 3x2 plus 6x3 plus s2, and it's going to be equal to 15. And then that's good. And then our non-negativity constraints, which we actually don't really need for now, so I'll leave them out. But it's still kind of implied. So now the next thing after we converted it into canonical form is that we can put it into a tableau. Now the tableau in itself has a pretty specific form, so hopefully you can kind of just follow the pattern. So basically on the left column we got BV, which stands for basic variables, and I'll explain what they are later. And then we've got a couple of columns, and then we've got x1, x2, x3, s1, s2, and then, so these are all the variables we have, and then we've got the right hand side. So, and then we'll just do that. Now what we want to put as numbers is basically the coefficients of each constraint, and the objective function actually goes in the bottom. So some other systems will do it differently, so this is the way I've learned it, and this is the way I'll teach you. So the first thing, the objective function goes at the bottom, and the other thing I forgot to mention is that the objective function, we need to rearrange it in such a way that we've got all the variables on the left hand side. So that becomes z minus 5x1 minus 3x2 minus x3, and then that's equal to 0. So that's going to go down to the bottom, down there, and then we're just going to take the coefficients, and so what that becomes is that it's going to be minus 5 in the x1 column, minus 3, and then minus 1. It has no s1 or s2, so those two are going to be 0, and then the right hand side is going to be equal to 0. Now the constraints we can put in actually as is. So the first constraint is going to be x1, x2, x3, and then 1 s1, 0 s2. The right hand side is equal to 6. And then for the second constraint, it's going to be 5x1, 3x2, 6x3. There's no s1, and there's 1 s2, and it's going to be equal to 15. So now the basic variable is basically the set of variables that have a number assigned to them. So and what they correspond to is what we call pivots, or leading entries, or leading ones, depending on what you've learned in linear algebra. But the main idea here is that here we've got leading ones here, and they're called leading ones because in the rest of the column there's ones in, everything else is a 0. So in this case, the slack variables s1 and s2 are actually our starting basic variable. So that's going to be s1 here, and that's going to be s2. So I want to point out that you've got the s1 here, you've got the 1 here, you've got the s1, and every other number in the column is all 0. Well, you don't need the z row to necessarily be 0, but that's the main idea. And then similarly for s2, you've got a leading 1 in there. So that's our starting tableau, and that's where we're going to start the simplex method with. Alright, so I might talk about a step-by-step thing, but essentially I'll kind of just very loosely describe it in a I guess in a very loose kind of way, and might not really be perfect in the way you replicate it, but you should hopefully be able to see the working. So step two, so the next step is that because it's a maximization problem, we want to choose the most negative reduced cost. So what do I mean by the most negative reduced cost? In that basically saying in the last row, so in the Z row, we want to choose the most negative number. And so in this case, this is going to be -5, which is corresponding to x1. What this means is that we are going to add x1 to the set of basic variables, but now we have to choose which one of s1 or s2 to take out. So basically, what we're going to do here is what we call the ratio test. So I'll just move that out of the way, and then I will do a little thing in pink. Okay, and then I've got a ratio test. So now the ratio test is what it, how do we do the ratio test? The ratio test for the variable that's going to come in, that's going to be x1, and then so we take the right hand side, so the ratio test is going to be the right hand side divided by the number corresponding to the variable that's coming in. So in this case, this is going to be 6 divided by 1, so it's going to be this 6 divided by this 1, and then that's going to be equal to 6. And then for the second constraint, it's going to be 15 divided by 5, which is going to be equal to 3. Now, what we want to do is that we want to choose the lowest ratio. So when we choose the lowest ratio, what happens is that we end up with this one. So basically, what happens is that x1 enters the basic variables, and then s2 leaves the basic variable set. Now, what we need to do now is that I'm just trying to figure out how I'm going to replicate this. So I'm just going to rewrite the table again. Okay, so we got the basic variables, and then we got x1, x2, x3. So that's 1, s2. So what we need to do now, and I think that is step 4, because I've kind of glossed over the other steps, is that we want to pivot the tableau. So notice remember what I said before about when you have the S1 and S2 as your basic variables, we've got the pivots. So what we want to do now is that now that we kicked out S2 and we're putting X1, we want to have the pivots as appropriate. So the kicked out S2, so S1 is still here, and then we've got S2. And then just gotta do that quickly, and then we've got the Z row, but now we have to do some calculations. So sorry, we don't want S2, we want X1. Okay, so what I've said before is that we want this to be a 1 here, but notice how we've got a 5 at the moment. So we've got a 5 at the moment, which means that we need to divide the whole row by 5. And the other thing is that as well, we want to have zeros in the same columns as the leading entries. So now so the operation we do here is similar to row operations in linear algebra, or if you haven't done linear algebra, it's kind of the same of adding simultaneous equations together or subtracting simultaneous equations. So now I'm actually gonna do a bit of a shortcut first. I'm gonna add row 2 to row 3 first, because it's easier to add 5 to -5. So I'm actually gonna do that one first. So just gotta make sure I'm doing things right. So that's gonna be row 3 equals row 3 plus row 2. That's linear algebra notation. If you don't quite understand it, it's not gonna be a big deal. So basically, it's gonna be 5 plus -5, and then that's gonna be 0. 3 plus -3, that's gonna be 0. 6 plus -1 is gonna be 5. 0 plus 0 is gonna be 0. 1 plus 0 is gonna be 1. And then 15 plus 0 is going to be 15. Alright, and then now hold on, just a little. Now what I'm going to do, is that I'm going to divide the second row by 5. So what's happening here is that, so for the second row, so this 5 divided by 5 is equal 1, and I'm just going across the row, sorry, that direction. I'm going across the row. 3 divided by 5 is going to be 3 on 5. 6 divided by 5 is going to be 6 on 5. 0 divided by 5 is 0. 1 on 5. And then 15 divided by 5 is going to be 3. And then, now what I can do is that I can take the first row, subtract it by the second row. So the first O row, that's going to be S1 up here, I'm going to subtract this row from it. So, and you'll notice that I'm kind of just doing things a bit visually. If you feel like you need to write out more the tableau to save yourself a bit of effort working, that's fine as well. So what I'm going to do here is, so it's going to be this one. So it's going to be that top one minus 1. So I'm going to get a 0 here. The top 1 minus 3.5, that's going to be 3 on 5, that's going to be 2 on 5. 1 minus 6 on 5, that's going to be negative 1 on 5. And then 1 minus 0, that's still going to be 1. 0 minus 1 on 5 is going to be minus 1 on 5. And then 6 minus 15, that's going to be negative 9. So again, we don't need to worry about the negatives so much. So what's actually happened? So, and then that's basically one iteration of the simplex method. And we'll point out the pivots again. Notice how we've got x1, we've got a pivot, a leading 1, where it's the leading 1 because we've got zeros in the columns. And then similarly for s1, sorry, I should use a different color. We've got s1 here, and then we've also got a pivot in s1. And then in the same way, we've got zeros in the rest of the columns where the pivots are. So now we're going to go back to step 2, because we've done the single iteration of the simplex method, and we're going to ask ourselves, are there any more negative reduced cost in the bottom row, in the Z row? And it turns out there isn't any. So it means that we are done and our solution is optimal. Now, there's a little thing where if you have a solution with infinite solutions, then you might need to find a set of solutions, but that is something for you to discover when you discover later. So what we do now when we read off the tableau is we read off the solution. So effectively, and I'm just going to quickly pull up my my notes just to make sure I've actually done all the calculations correctly. But what we do now is that we can basically read off the basic variables and say, okay, our solution is corresponding to the basic variable. So just gonna check this pretty quickly. So it looks like I'm going to divide the whole row by 5, and then we got 6 and a 15. I made a mistake. My apologies. So that one should be 3. And then just gonna correct some of my mistakes that I made. So 2 on 5, that should be negative. That should be 9 on 5. 1 and then negative 1 on 5, that's going to be a 3. Okay, there we go. And then 5, 0, 1, 15. Okay, we're fine now. Okay, so our solution, so our optimal solution is going to be so as I said before, the basic variables are the ones that have numbers and everything else is set to 0. So so basically, like the way you write out one way you can write out the solution is basically x1, x2, x3, s1, s2, and it's going to be equal to, now, so x1 you read across and the right hand side, so that's going to be equal to 3. And then, so x2 is not a basic variable, so it's going to be 0. x3 is not a basic variable, so it's going to be 0. s1 is a basic variable, so we link that to the right hand side, so that's going to be a 3. And then s2 is not a basic variable, so it's going to be 0. So that's going to be our solution, and effectively this is saying that our optimal solution only in terms of x1, x2, x3 is going to be 3, 0, 0. Now, the s1 and s2 is actually what seems to call slack variable. It means that one of the constraints is not fulfilled to optimality, but we will look at that. We will look at that a bit later. So for now, we've got our optimal solution, and then we've got our optimal value of 15, which is just simply this number there in the bottom right. So that's how the simplex method works with one simplex iteration. In the next video, I will do an example with the simplex method with 3 iterations. So it will be a bit long. I'll probably make a lot of mistakes along the way. So hopefully that will get you a bit to be a bit prepared against what to expect. So until then.